welcome back. So, yesterday we started talking about exponential functions. Y'all remember the zombie activity thing we did? You keep it, it is what it is. But today we're actually going to start the notes, technically. That way I can get you the assignment. We'll have that today, but also you'll have some time to work on it tomorrow. Cool? Now, you do have a quiz next Wednesday. That's notable. But, yeah. So here we go. Remember yesterday we had one strand of zombie outbreak, which was adding 3 each time. And we said that was linear. So when you add each time, that's a linear function. And then the second strand was a zombie infecting one more zombie each time, and we saw that was multiplying or doubling each time. Okay, so this strand is a little bit different. Okay, this is a third strand of zombie infection, and each day one zombie infects 2 new zombies, makes 2 new zombies, right? So here's the deal. This might sound exactly like yesterday. If you have 2 new every time, isn't that just doubling? But I must tell you, that is not true. Watch this. By the way, my pen is kind of acting up, so we might have some issues here. But let's call that Z a zombie. If that zombie infects 2 new zombies, watch this with your eyes. Look. How many zombies is that? 3. I know this is hard high school math, 1 plus 2, but it's 3, right? Okay, so here's the deal. When I take the original zombie and he infects 2 more, that actually gives me 3 total. Now watch this. The next day comes around, and each of these zombies infects 2 new ones. So watch this. This first zombie still does 2, and the 2 new zombies create 2 new zombies of their own. So notice, I didn't double it, I actually tripled it, okay? So here's what I want you to notice. That's why I have a little blank here. When you have 1 original zombie and you have 2 new, that means you're multiplying by 1 plus 2, which is 3, okay? So when you're adding 2 each time, don't forget the original one. 1 plus 2 is 3. So what we're doing is multiplying by 3. So here we go. Let's fill out this table, okay? When you have a zombie outbreak, you got to have your starter zombie. You don't start with 0, you start with 1, okay? Don't ask me how the zombie came to be. It's a mystery. But there's a zombie. 1 zombie is what you start with. And like I just said, we're going to triple it. We're going to multiply by 3 each time. So remember, we had that 1 zombie, and then after day 1, now we have 3 zombies, right? Because that 1 added 2 more. Now, if we're just multiplying by 3, on the next day, we're going to take that 3 times 3. What's 3 times 3? 9. Okay. Very good. And can't you see that right here? We have a 3 by 3 block of zombies. That's 9 zombies total. Okay. Now, I'm not going to draw these anymore. We're just going to use our brain. We're multiplying by 3. What is 9 times 3? 27. And what's 27 times 3? Huh? 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 81. And then what's 81 times 3? Huh? No, you. Yeah, 81 times 3. 243. Very good. Now, do you see kind of what we talked about yesterday? Exponential growth grows exponentially, meaning it grows very fast, right? So we're not. No. All right. Hey, for real though, I need y'all to lock in. Okay. This whole unit is based off today's notes. And it's not that hard, but you gotta hear what I'm saying for sure. So there is not one reason to have your Chromebooks open. I'm not gonna lie. You're gonna be looking up here and writing stuff down. So when your Chromebook's open and you're doing glancy eyes, I know you ain't paying attention. So let's get locked in here. Now, let me pass this out. Got some notes to do, right? Hey, your friend? Did she move away for real? Yeah, she's on a roll, so she needs to unenroll.
Still on your roll.
I know. Because some people move without telling the school, and then we're like, what happened, you know? Well, but the parents need to talk to the front office. But I digress. Here we go. Let's get through this. Y'all want to get through this quickly, or do you like hearing me talk? Okay, well, but in all actuality, I'm sure y'all would like to talk to each other and, you know, kind of chillax. So if y'all just please stay focused on me and the notes and answer my questions, it'll be done faster. You know what I'm saying? All right, here we go. Let's talk about exponential key features. So the exponential key features, our learning target is we want to identify key features. That's in the name of an exponential function from a graph and an equation. All right, now check it out. Here's our success criteria. I know I'm learning when I can identify a what? The heck is that word? Y'all seen that word before? I'm interested. How do you think you pronounce that word? Asymptote? Asymptote? Okay, no. So the way you say it, the P is silent, like in pterodactyl. Y'all know pterodactyl has a P in it? Like phone. Starts with a P, but you don't say pone. Anyways, so the P is silent. That's all I'm saying. It's asymptote. Asymptote. Cool? Just so you know what I'm saying when I'm saying this word. Asymptote. Now, I'll tell you what it is before we get started. But the way I'm going to tell you is through a pop culture reference. All right. Do y'all know who MC Hammer is? Hammer time? You know? I mean, he was popular before y'all were born, so I understand if you don't know who he is. You know, he did that cool dance, you know? No, that's the other way. You know, he did like the. Anyways, MC Hammer had a very popular song called "Can't Touch This." Can't touch this. Can't touch this, right? So here's the deal. What is an asymptote? It is something you can't touch. That's it. It is a line that you cannot cross. It is a boundary that you cannot touch. All right? And here's a way to remember it, okay? Now, y'all are smart, right? Okay, y'all are clever, and y'all like goofy little things. And I'm not trying to be vulgar, but I want you to catch what I'm laying down here, okay? Here's an easy way to remember it. A exponential function cannot touch the asymptote. You cannot touch the asymptote. Do not touch that. That would be wrong to do. If you catch my drift. Okay, well anyways, let's keep going. Exponential key features from graphs. You need to fill this in. I'm going to type it because my stylus is acting up on me. What do you call this point right here on this axis? What's the name of it? Thank you so much for answering my question. Next person needs to answer it over here, right? Y-intercept. So write that down. I'm typing it, you're writing it, because this is the y-axis, right? Y'all know that? Now, here's that new word we just learned. My screen is green, on this paper it's not, but see this dashed line? And you see how the graph is getting closer and closer and closer to it? And I know it looks like it touches, but it never actually touches it, because you can't touch the asymptote, okay? I know it looks like it does, but it's really just getting closer and closer and closer and closer. It never actually gets there, okay? Let me give you an example of what an asymptote is, okay? If I told you to take the number 1 and cut it in half, what number would you have? 0.5. Now, can you cut that in half? 0.25. And can you cut that in half? 0.125. And can you cut that in half? You get the idea. Any number you can cut in half, and it gets smaller and smaller and smaller and smaller, but does it ever actually equal 0? No. Okay, 0 is not half of any number. 0 is nothing. So it's very important that we know that just because it gets closer and closer and closer doesn't mean it's ever going to get there. Sometimes it doesn't. And that's why we have, in math, what's called the asymptote. So let's write that in here. Don't forget to spell it right. Asymptote. So whenever we have exponential functions, they're always going to get closer and closer and closer to this line, but never touch it, never cross it. Okay? Now, there's two types of graphs right here on the screen. Does everyone see this one on the left? Make sure you're looking up here and not at anything else. So I don't think you're doing something else when you should be looking at the notes up here at the front. Make sure you're looking at the front. Hey, if you're new to my class, look over here. Sorry. Focus. Now, the graph is what from left to right? So as it goes from left to right, like Mario World, like we're reading, we're going to the right. This one is going up. It's increasing. Write that down, please. Increasing. What do we call this graph if it's increasing from left to right? That makes the relationship an exponential growth function. Everybody, if it goes up to the right, it's called exponential growth. Okay? Now, let's see if y'all can figure this one out. What if it's going from left to right, downwards? Well, that would be decreasing from left to right, right? And here's the question. That would make it an exponential what? What's the opposite of growth? Decay, all right? So you're either growing or you're decaying, you know what I'm saying? Luckily, we're all growing. So, exponential growth up to the right, exponential decay down to the right. But it's always going right, okay? Can you wait for the notes? This is like brand new stuff you gotta know. So, here we go. Let's do some examples. Does anyone still need this? Okay, check this out. Here's some examples. Now, I know there's an equation. For now, we're gonna forget the equation, and we're just gonna look over here at the graphs. So looking at this graph right here, what is the y-intercept? Where does it cross the y-axis? Anybody? Where is it? 3, right? Now, if you just put 3, that's okay, but I want you to know that it's a ordered pair. It is 0, 3. That's the coordinate pair point that we need, okay? Now, this is new, brand new. You got to know this. The asymptote is right here in green, right? You see it? It's going left to right. It's a dashed line. But you got to know the equation of it. And I know we just did this last year. But yeah, last semester we talked about this, but sometimes we forget or we get confused. So let me remind you. Whenever you have a horizontal line, you need to ask yourself, what axis is it going through? So when this horizontal line hits this axis, what is this up and down axis called? X or Y? This goes faster when you respond. Anybody? So what axis is up and down, vertical? What is the up and down axis called, class? Thank you. No, it's the y-axis. Okay, somebody new will answer now. Okay, we can make this as slow and painstaking and don't go to the restroom until this is all done. Or you can answer my question. You know what I'm saying? Y'all aren't too cool. None of us are cool. We're all in math class. Okay. All right, so check it out. Y. So here's the deal. When it's a horizontal line going through the y-axis, you're going to write y equals the number. What number does it go through? When it's the origin right there, it's It's going through 0, right? Now let me give you a peek behind the curtain here. In Algebra 1 this year, we are not going to do anything fancy with exponential. Okay? We're not going to shift it up, shift it down, stretch it up, stretch it down. We're not going to shift it left or right or rotate. We're not going to do anything crazy. That's like Algebra 2. That's later, maybe in 2 years. Okay? So here's the deal. Every time you do this, the asymptote is going to be y equals 0 in Algebra 1 this year. Okay? So for the STAR test, for my class, y equals 0, that's your asymptote. Easy? Cool? Doesn't change? All right. Now, you tell me, with your voices now, is this growth or decay? What do you think? Ah, growth. Thank you. So, everybody, do you see why this is growth? It goes up to the right. It's growth. Now, domain and range. Let's think about this. Do you see that this graph goes to the left forever and ever? And it goes to the right forever and ever. Okay? It never stops decreasing to the left. It never stops increasing to the right. So when it's all the numbers that you could possibly think of, the way we say that in math is all real numbers. You may have seen it with this little symbol that looks like an R with an extra little line through it. Okay? That weird R is all real numbers, which basically is the same thing as saying negative infinity to positive infinity. The other way to write it is like this. Negative infinity is less than x is less than infinity. Does everyone remember that domain is x and range is y? Okay, we definitely went over that this school year, even if it wasn't this calendar year. Okay, so it's been a few weeks, but remember, domain is from left to right, horizontal x, range is from bottom to top, vertical y. Now, the range. Do y'all think the range is all real numbers? Let's think about it. How far down does this graph go? Does it go down forever, or does it stop right here? The asymptote is right here, so it does not go below 0, right? You can't cross this line, can't touch it. So the difference between domain and range for a exponential function is that the range, the lowest it can go is 0 without touching it, so we do not underline it. Got to put y because we're talking about range, but it does go up and up and up forever, so that is positive infinity. So let me tell you again something. Here's a little important bit of information. This asymptote, domain, and range are always going to be the same in Algebra 1 this year, okay? So when you see these questions, they're going to be those answers every time, because we're not doing anything weird with these exponential functions, okay? So again, I'm giving you some freebies, as long as you're hearing what I'm saying. Now, let's do another one. Looking at this equation, what's the y-intercept? Where does it cross the y-axis? Right here at 2, yes. Okay, so again, this is y, it hits right here at 2. So how do we write that? 0, 2, right? And I just told you, so hopefully you remember, what is the asymptote going to always be? Y equals 0. Because look, my dashed line goes through 0 horizontally through the y-axis. So y equals 0. Cool. Now, is this growth or decay? As you go to the right, it's going up or down? Down slowly, but this is going down, so it is growth or decay? Decay, all right. Down to the right, right? And what did I say about domain and range? It's always the same, because it goes forever to the left, forever to the right. So go ahead and put negative infinity, less than x, less than infinity, and the range doesn't go below 0. So 0, less than y, less than infinity. Make sure you have that down and flip it over. We got a few more things to talk about with the equations, and then I'll be out of your hair. Here we go. Backside. This is the most important part. Okay. Anyone still need this on the board? Can you shut that Chromebook, because I want you locked in here. Okay. We're waiting on you, and you were looking at your Chromebook when I was talking. You know what I'm saying? But I saw it. But I saw it. What? Thank you. All right, next page. Now, everyone, for real, this is the most important box. This is going to get you through this whole unit, and this is what you got to know for the STAR test, okay? Again, we want you to be successful on the STAR test, not have to take it more than once. So check it out. The form of an exponential function is a times b to the power of x. What makes an exponential equation an exponential equation is when the exponent has x. So when you see a little x up top, it's exponential. So check this out. A is your starting point, initial value, or y-intercept. Please write that down. So you're going to have two numbers here. This first number is your y-intercept. Okay? Now, what if there is no a value? If there's no a value, that means a equals 1. This was like first week of this class, right here. When there's no number in front, that means there's a 1 in front. Right? Look up here. Invisible map. No number in front, that's a 1. Okay? So again, a is your y-intercept, and then write this down. If there is no a equals 1. Now b, some people call it the base, but what it is, it's the rate of growth or decay. Cool? So this number right here is going to tell you, is it increasing or is it decreasing? And here's what you got to know. Growth and decay. So, hear me say this. If your b value, this number right here, if it's bigger than 1, it's going to be a growing exponential growth equation, okay? So what numbers are greater than 1? Obviously, 2, 3, 4, 5, blah, 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 right? But you also need to know there can be decimals and fractions that are greater than 1. Like if you see 1.5, that's growth. 7/2, that's greater than 1. That's growth. Okay, so I don't want you to think it's about fractions or whole numbers. It's about, is it greater than 1? So again, greater than 1 is growth. Decay, now look, like, let me see your eyes, look over here. Between 0 and 1 is decay. What kind of numbers are between 0 and 1? Y'all got this, I know it. What kind of numbers are between 0 and 1? Think of one number between 0 and 1. 0.5. Decimals and fractions, right? 1/3 is between 0 and 1. 0.6 is between 0 and 1, okay? So they got to be smaller than 1, but greater than 0. That's going to make it decay. All right, this is going to be fast, I promise. Let's do these 3, and then I'll be done. So, first things first. When I look at this, I got 2 numbers. Which one of these is the y-intercept? Which one of these, y'all are making this like the slowest possible thing we can do, so be my guess. But what is the y-intercept, class? Thank you, 10. Okay, got the same 2 people answering. Now, when we write 10, we're going to put it as an ordered pair. Okay, so 0, 10. Okay. All right. Now, if you remember what I said on the other side, asymptote is always going to be y equals 0 for this class. Y equals 0. Now, how do we tell if it's growth or decay? Look at this number right here. Is this number greater than 1? 7 is greater than 1, so that's going to be growth. Cool? Not too bad, right? And then what else did we say about domain and range? It's always going to be x is all real numbers, or negative infinity, positive infinity. And the range is always 0 to infinity. Okay. Do you see how this works? The first number is the y-intercept. The second number tells you if it's growth or decay. And you know asymptote, domain, and range are always the same. So let's look at the second one. What is the y-intercept here? Which one of these is the y-intercept? The first one, 1 over 3, is my y-intercept. So I'm going to write 1 over 3, or actually 0, comma, 1 over 3. What's the asymptote always going to be? Y equals 0. Now, growth or decay. Look at the second number. 6 over 5. I know it's a fraction, but is it greater than 1 or less than 1? Is 6 over 5 greater than 1 or not? Now, I understand if fractions aren't your jam, what could you do to figure out if it's greater than 1? Could you put this fraction into Desmos and turn it into a decimal? So I'll tell you, if you type this into Desmos, it'll say 1.2, and 1.2 is bigger than 1, okay? So here's how you know this. If the top number is bigger than the bottom number, it's greater than 1. It's a growth function. So go ahead and circle growth, okay, because 6.5 is 1.2. That is greater than 1. All right, and then y'all know domain and range is always the same. Negative infinity to positive infinity. 0 to infinity. Last one, and then we're done with the notes. What is the y-intercept here? Which one of these numbers? Okay, that first one, 2.71, right? So how do I do that? I put x is 0, 2.71 is my y-intercept. Make sure everyone's writing this down. We're almost done. The asymptote we said is always y equals 0. Now, is this growth or decay? So look at this number in the parentheses. Is this greater than or less than 1? 0.9. Is that greater or less than 1? A little bit less, right? If it's less than 1, if that's a 0 point something, then it's decay. Okay? 0.97 is less than 1. This is a decay function. And your domain and range is going to be the same as before. Again, you're always going to have the same domain and range and asymptote. And all right, I'm sorry it's sloppy, but I'm having issues with my stylus. So I'm going to pass out this assignment. You can start it today, but we're going to have time to work on it tomorrow. But that is the notes. You've got to know the top of this back page. You have to know that this here. Okay, here we go.